My name is Pat Gunn. I'm with the CMULAB project at Carnegie Mellon University, which is part of the Protogenie control framework. And I'm presenting today MetaVPN, which is a tool that allows for configuration and management of multiple OpenVPN instances. An OpenVPN is a popular open source VPN software that allows for creation of layer 2 and layer 3 networks. But the problem with using OpenVPN in a testbed is that it has a fairly involved configuration routine, which involves generation of OpenSSL keys and fine-tuning of a config for both servers and clients. And so, in order to take advantage of the features of OpenVPN, in order to take advantage of the features of OpenVPN, it's desirable to wrap that, and so MetaVPN is that wrapper. Now, one of the uses of these VPNs is to bridge between private and public testbeds. Now, a private testbed is a testbed where the nodes don't actually have IP addresses that are publicly accessible, which happens to be the case at Carnegie Mellon. Now, in order to allow those nodes to participate in an experiment with nodes that are public, we use an OpenVPN network that's hosted on one of our public systems in CMU's testbed, and have all of our nodes that are part of that testbed, as well as the other nodes that are in the experiment, join that VPN. Another use is to provide layer 2 connectivity between nodes, which is useful either in our particular network situation with the private testbeds or between two public testbeds. And so how MetaVPN works is it provides a command line interface that through which people can configure the server. Now, a MetaVPN server is typically running on a particular port, and it knows whether it's layer 2 or layer 3. And so through the command line interface, people will specify those parameters as they're establishing the network. And after they configure the network, they'll add all the nodes that need to be part of the experiment using that interface to the VPN, and then they'll typically bring it up. MetaVPN provides easy ways to do that, along with ways to then automatically generate a configuration and generate OpenSSL certificates, and then deliver those to the nodes, which will then run the OpenVPN client software against them to join the VPN. And so the basic goals of this are to eliminate the unnecessary complexity of configuring and managing multiple OpenVPN instances, and only expose the details that are relevant to those who are going to be running a testbed. It's usable either reasonably integrated with the CMULAB/Protogenie control framework, as well as separately, and it's scriptable so that people either in other control frameworks or outside of the context of a testbed would be able to make use of it.